Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. So today we're going to start with chapter 10 on mechanical wave and sound, where this chapter have 5 subtopics. The first one is properties of wave, second superposition of wave, sound intensity, next is application of standing wave, and the last one is Doppler effect. So today we're going to look at 10.1 properties of wave. In 10.1, we have 4 learning outcomes to be covered. Define wavelength and wave number, solve problems which to be solved in tutorial, discuss and use particle vibrational velocity, and discuss graph of displacement against time and displacement against distance graph. 10.1 properties of wave. There are 2 types of wave. So you have the first one is progressive wave, where for progressive you have longitudinal and transverse wave, and second is stationary wave. So we're going to look at what is progressive wave for longitudinal and transverse wave.
Waves. One of the first things we need to know about waves is there are 2 different types of wave. One shown here by waves in the sea, and the other one shown by sound waves. So how are they different? Well, first let's look at the sea waves. If we look at them represented with this slinky, we see that the vibrations are at 90 degrees or perpendicular to the direction of travel of the wave. These are called transverse waves, and examples of them are waves in water, waves on a string, or light waves. Now let's look at the sound waves again. Again, we see them represented by the slinky, but this time the direction of vibration is parallel to the direction of travel. These are called longitudinal waves, and the only example you really need to remember is sound. One really important thing to remember about waves is they only transfer energy from place to place, not any matter. And we can see that here by looking at a lovely rubber duck sat in a bath. As a wave goes through, the duck bobs up and down, but once the wave's gone, he's back to his original position. The wave has carried energy through, but it did not carry the duck with it.
As what we have saw just now, so the first one is progressive wave, where progressive wave is a wave that propagated continuously outward from a source of disturbance. Okay, there are a few types of a few shapes of wave, where the first one is sine, second square, triangle, and this is a sawtooth wave. For matriculation syllabus, we're going to look at the first one, which we call a periodic sinusoidal waveform. So what do you have to know in this chapter? Now, first, when you have a graph of y against x, what should you know is, now this top is crest, and at the bottom we call it as throw. Okay, we have first displacement in terms of y, where y defined as the distance moved by particle from its equilibrium position at every point along a wave. So as the particle goes up and down from a wave, because you know wave is made of particles that goes up and down, up and down. So this is your y displacement as the particle goes up and down. Next, amplitude. Amplitude is the maximum displacement from equilibrium position. So your equilibrium position is this origin to the crest or throw of the wave motion. So as it goes up to the maximum, this is positive amplitude. As your particle maximum but downward, this is a negative amplitude. The value of your A will be the same. Next is period. Period, okay, before that, what is the difference between y and x? As I mentioned before, y is as particle goes up and down, and x as your wave travels to the right or to the left. So the distance traveled by the wave is x. The particle displacement is your y. Okay, period. Period defined as the time taken. Now we have two types of wave. The first one is a graph of y against x. The second one is a graph of y against time. So, okay, now for a graph of y against time, you can determine its period from this graph. What is period? Period is defined as the time taken for a particle in the wave to complete one cycle. In this period, the wave profile moves a distance of one wavelength and its unit is second. So this is one cycle, starts from origin and back to origin. One cycle from origin, travel and back to origin. This is two cycles. So this is one cycle. Then from here to this point here, this is another cycle and so on. The time taken to complete one cycle is what we call period. Frequency defined as the number of cycles produced in 1 second, where the unit is hertz, and the formula will be period is equals to 1 over f. Wavelength is defined as the distance between two consecutive particles which have the same phase. When you have a graph of y against x, so the distance between two consecutive particles, okay, for complete one cycle, this is your wavelength. Example, from B to C, okay, this is one wavelength, or P to Q, one wavelength, S to T, one wavelength. But let's say you have another point of A here. Okay, now P and A is not wavelength because P and A is not in phase. It's not same phase. P goes up while A is going down. So point P and A is not in the same phase. Unit for wavelength is meter. Okay, wave number defined as the number of wave in a unit distance, and the SI unit for wave number is equals to radian per meter or per meter. Formula to calculate K equals to 2 pi over lambda.
Finally, we need to know some key features of waves. First off, wavelength. A wavelength is the length of a full cycle of a wave, from one point to the next same point. It's easiest to think of as the distance from crest to crest or from trough to trough. And we measure it in meters, and it's given the symbol lambda, a nice Greek symbol. The amplitude is like the size of a wave, but we need to remember that it's measured from the equilibrium position, or the central line, to the crest, not from the crest to the trough. Finally, frequency, which is the number of complete waves to pass a point every second, and it's given the unit of hertz. So an example of this would be if 10 waves pass in 2 seconds, the frequency would be 5 hertz. Using these things, we can actually now calculate the speed of a wave using the equation speed equals frequency times wavelength, or to give it in symbol form, V equals F lambda. So there's a lot to learn here, but once you've learnt these core concepts, it will give you much more confidence in the rest of the topic.